Okay, so another example on node voltage analysis. So the problem wants us to find the currents, but first let's look at the essential nodes, find the voltage of the essential nodes, and we go from there. Okay, so essential nodes, I see a node here, node here, basically they're both connected, so there's just one node, and there's one node here. So let's put this as a reference. We go to 0. Okay, so after doing that, good thing is just to look at, see if you see any voltage source, and you can find voltage of some of the nodes for free, basically. So for example, if you look at here, if this is 0 and there's a voltage source 80 volts, it means that the voltage here is 80 volts. Okay, so this is the case, again, a special case when an essential node is between the reference node and a voltage source, or in other words, I put it in a better word, there's a voltage source between an essential node and a reference node. So if that's the case, so exactly we know what would be the voltage of this node. So there's no need for write any KCL anymore. Okay, so this is a good case, can happen. So 0 here, 80 volt here. So we know the voltage of the whole thing here is 80 volts. Okay. Also, if you look at here, there's another voltage source here. And look at the direction. So the direction, based on the direction, what would be the voltage here? The voltage here would be negative 30 volts. Why? Because this is 0. And based on the direction, it says this node has a 30 volt less than here. Okay, so it's negative 30 volts. Okay. So after doing so we simplify a lot the circuit, because as you see, the only unknown voltage here would be this V1. Okay, so we write the KCL here. So the KCL at V1 will be the current here, which is V1 minus the other voltage of the other side, which is negative 30, divided by 5K, plus the current going down, V1 minus 0 divided by 500, plus the current going there, 10 milli, good. And then the voltage, the current up is V1 minus 80 divided by 1K, go to 0, right? As you see, there's only one equation, just because there was just one essential node whose voltage was unknown. The other ones we already know, thanks to these voltage sources. Yeah. So because this is a simple equation, let's just solve it. I would just multiply the whole thing by 5,000, basically. 5K. So I get V1 plus 30 plus 5,000 and 500, so it gives me 10 V1 plus 5K times 10 milli gives me 50 plus 1K and 5K, 5 V1. And I get the minus 400, equal to 0. So 10, 15, 16, V1, 80, minus 400, got 0. 16 V1 equal to 400 minus 80, which is 320. So V1 is 220 divided by 16, which is 20. Very good. So V1 is 20 volt, and then the problem wants us to find the currents. So let's do that. I will replace here the V1 by 20. Okay. That's a good practice here, finding the currents. I1. Okay, look at the direction. For I1, again, direction, look at the beginning, which is minus a negative 30, minus the other side of that, divided by 5. Negative 50.5K, negative 10 milli. This is I1. Now look at I2. Again, look at the direction. The beginning minus the end. The beginning voltage is 20 minus 0 divided by 500. Now look at I3. Okay, now to find I3, that needs some attention here. Okay. So I3, the current here, so basically the summation of these two currents, right? So these two currents come and then they form I3. So let's calculate these currents here. Again, we look at the direction, the beginning minus 8, so 20 minus 80 divided by 1K. So negative 40 divided by 1K, negative 40 milliamp. Okay, so this is this current, negative 40 milliamp. And then this current is basically summation of this, 10 milli plus this. What is the current here? 0 minus 80 divided by 4K, negative 20 milliamp. Okay, very good. So let me change the color here. Negative 20 milli, 10 milli. And if I call this I4, the I4 is equal to the summation of this 10 milli and negative 20. So negative 10 milliamp is I4. And then I4 plus this current plus that current is negative 40 milliamp is equal to I2. Right? So I4 is negative 10 milliamp. So minus 40 comes negative 50 milliamp. Okay, so I think I made a mistake here in the calculation. 20 minus 80 was negative 60. 60, so this is 60 milliamp. And then this is also negative 60 milli. Minus 10, minus 60, minus 70, sorry. Negative 70 milli. Oh, correct.